Hi, everyone. Welcome to today's NVIDIA Omniverse OpenUSD Insider live stream. I'm joined by my fellow colleague here, Eric Bowman, aka Strainful. Hey, Eric.
Hey, it's good to be here.
This is an exciting one. We're going to dive into
Oh,
generating synthetic data for physical AI. We have some very special guests waiting in the wings, but Eric, we had a really fun time in this rehearsal the other day, didn't we?
yeah. I
I
mean,
think
we've been talking about Cosmos for a little while now.
we have, and I think that
Or,
what people will see in terms of the demo we'll give is going to be very compelling. So
yeah,
get ready for your questions and comments. You could post it in the live chat. You could start off by telling us where you're watching from, and if you have any interesting robotics or related projects that you're working on. It's always great to see those shared in the community and let others jump in and celebrate with you. Before we start the show and bring in our special guests, we're going to go over a couple of quick things, starting with SIGGRAPH 2025, which kicks off next week in Vancouver. I'll be going there. My producer Amelia, who's working in the chat right now, she'll be going as well, but as well as a bunch of NVIDIAns. So we're very excited. We hope that people who can attend physically can make it. We have a code we'll put in the chat, which gives you access to the free Expo, as well as a handful of other things with that free code, or gives you discount on the bigger pass. If you're not in the area, there will be some great content streamed live, including what's on the screen right now in these very special sessions. That QR code will bring you to a page that gives you full information on these sessions, but we highly encourage everyone to add this to your calendar. Just follow that code. It's going to be a great event to watch live. There'll be a lot of discussion on SIGGRAPH all week on our Discord server, where we have a special SIGGRAPH channel. Encourage everyone to jump in there as well. We have a very special day at SIGGRAPH revolving all around OpenUSD. As many people in our community know, we just launched the certification for OpenUSD. Super exciting. We already have a couple of great members of the community who jumped on right away and got their certifications. Congratulations to Nandu and also Austin, two of our Omniverse ambassadors who might be watching right now. So good on you. They leverage the learning path for OpenUSD to help them prepare. We'll post those links in the chat. But at SIGGRAPH, we actually have sessions throughout the day on August 13th revolving around OpenUSD. That QR code will give you more details on each of those sessions. You'll see me there. If you're coming, I'll be hanging out all day. If you're interested in meeting, we also have great opportunities to meet with the team. Let me know if I can help with that. We also have training labs. Look at all this stuff on OpenUSD and robotics. There's going to be something there for everybody, no matter what your experience level is. So check out that QR code. And there's that discount code I just mentioned a second ago on the screen that will give you, like I said, not only complimentary entrance to the exhibit, but also there's a bunch of other items that you can access during SIGGRAPH. So it's actually
does that give you access to the NVIDIA sessions? I think I heard.
Not all the sessions, but I
But
believe
some of them.
Yeah, let me see. Actually, when we kick off the stream, I'm going to switch gears for a second. I'll paste the list of things
Yeah,
in the chat. So, because it's actually a
got it.
pretty nice list of things, but there are some sessions that the Expo Pass covered. I don't think all of them, based
Cool.
on the way that the SIGGRAPH is set up, the rooms and everything.
Sure.
But super exciting time. We're pumped about it. So I hope everybody can join us. We'll also have the OpenUSD developer meetup happening. A nice celebration. And I hear there's a little GPU giving away happening. Another reason to come. These are always great opportunities to meet other developers from the community, from different companies, as well as other NVIDIAns who will be there. It's just fantastic. There will be a room full of experts on various topics. Highly encourage you check out that QR code to find out more. We've also set up a very special WhatsApp group. This is to share information in real time with those who are attending SIGGRAPH 2025. So if you're going to be there, go to this code and jump on the WhatsApp group. We can set up coffee dates, lunch times, hang out for dinner, and of course, help you with anything you might need while you're on the ground at SIGGRAPH. So Amelia and I love having that group at every kind of live event. It's super helpful to everybody and a lot of fun. Lots of great introductions happen as a result of people jumping in there. As I mentioned, we just launched the certification for OpenUSD, and at SIGGRAPH, you can actually get certified and take the exam at the show. That QR code will show you more information there. It's an excellent opportunity to take advantage of the experts that will be there and get the exam out of the way with a great tutelage from other NVIDIAns and people in the community. So earn that badge and feel free to display it proudly on your LinkedIn page. There's also an NVIDIA AI podcast we'd like to bring your attention to, Bridging the SIM to Real Gap with OpenUSD. That QR code will bring you to that podcast. Lots of great live streams of podcasts happening across the board, actually. Amelia and I have been working with several teams, including from the NVIDIA developer community, who's been producing some awesome stuff. So check out this content from the NVIDIA AI team. And of course, for general reference, we have our QR codes that will bring you to our calendar, so you can see all the upcoming office hours, the study groups, the live streams, any kind of special events and keynotes, our official support forums for things like Isaac Sim, our Discord server, which is where you can engage with other developers in the community as well as other NVIDIA developers. And we have our community page, which lists all of our ambassadors if you're interested in learning about all the resources we provide, as well as touching base with some of our ambassadors in the community. So anyway, lots of great resources, including great resources. Oh my gosh, we have a ton of great resources today on Cosmos. We're going to dive in and let people learn about generating synthetic data for physical AI. It's going to be super exciting. So let's start with bringing up my great colleague, Asari. How are you doing?
Oh, you're muted. Oh, there we go.
Yep. Hey everyone, doing good? Can you all hear me fine?
Yeah, sounds great.
Okay.
Awesome. Okay. Yeah. So I'm Asavri and I work on some of our physical AI and robotics platforms. So things like Cosmos, what we'll be talking about today, Isaac Sim, which is our simulation platform, Isaac Lab for reinforcement learning, all of these really cool platforms and technology I kind of get to use. And I'm just excited to share a little bit about that today.
Amazing. And we have two very special people, right, that you work very closely with. We have Jan. Hi, Jan.
Hello, everyone. Great to see you all again. Yes.
Great to see you. Do you want to remind everybody, you're a veteran of the live streams now, but do you want to remind everybody who missed you last time what your role is here?
Yes. So I'm a principal engineer and also senior engineering manager at NVIDIA, currently leading the Isaac local manipulation team that we are working on the local manipulation for the mobile manipulator and also humanoids.
Amazing. Well, thank you so much for coming. I was saying earlier, Eric and I had a really fun time in the tech warm-up. I think people are going to be blown away by what you've all prepared today. Speaking of which, we have one more very special guest. Aigul, how are you doing?
Thank you. Good. Hi, everyone. My name is Aigul. I'm from Kovislam team and also work in robotics department.
Well, we're very happy to have you and also very grateful that you're staying up late. It's actually pretty late for her right now. I think it's after 10 p.m., a little bit past her bedtime maybe. So thank you for staying up. So we've got a lot to cover. Asari, why don't you kick us off? And I see I have your slides here. I'm gonna show those on the screen for everybody else. But yeah, let's talk about generating synthetic data.
Awesome. Okay. So today's topic is a super vast one. We're going to be talking about synthetic data for physical AI with NVIDIA Cosmos. So there's a lot of concepts and a lot of topics over here. We'll be starting with what is physical AI? Why does it need synthetic data? How do you generate that? So I'll do a little bit of like context building in the first few minutes. And hopefully that will kind of paint enough of a picture as to where Cosmos comes in. How do we use it? Why do we need it? So let's get started. The agenda for today. It's a lot to cover in the time that we have, but feel free to ask questions and we can always dive deeper into each thing. But I will start with talking about what physical AI is and what are some of the biggest challenges to developing physical AI today. Then we'll be talking about using synthetic data as a solution to one of those challenges and how the NVIDIA Cosmos platform can help you generate that kind of synthetic data. Within the Cosmos platform, there's a whole lot of different models and tools. We'll kind of be zooming in on one specific model called Cosmos Transfer. But then also at a high level, I'll be talking about some of the other models that are part of Cosmos. And then we'll be talking about the X mobility workflow. So this is an actual use case or an application of Cosmos to a problem that some of the teams at NVIDIA are solving in the AMR, which is autonomous mobile robotic space. So we'll be seeing a very real application of how Cosmos Transfer helped them increase performance, improve performance of their models.
Well, and that's in the real world, right? I mean, they're solving. We're not just solving problems in sim. This is like a transferred to solving a real world problem.
Absolutely, yeah.
Using
it's like
Cosmos.
It's like a real to real, improvement in the real world. So it's pretty cool.
Which we've been talking about the possibility of that, but today we're going to get to show it.
We're actually doing it. Yeah.
Yeah.
Absolutely. Okay. So again, some context building at first. What is physical AI? So any sort of embodied system that uses a brain or that needs to perceive its surroundings and then take actions based on its surroundings, that's physical AI. So some examples of this would be robots of different forms, shapes, and sizes. Of course, you had like humanoid robots. You have quadrupeds, which are like those four-legged dogs that you see. Then you have AMRs, which are autonomous mobile robots. And these are smaller, not exactly autonomous vehicles, but just smaller like terrestrial robots that probably you've seen working in factories and warehouses. All of these come within the physical AI domain because not only is there a hardware aspect to it, in that, of course, there's the physical embodiment and you have to work on the motors and actual actions. But there's also the software component to it, which is the AI part, the artificial intelligence part. And that is the part that uses all the sensor information. So for example, on your robot, you can have information about your world coming in through a whole bunch of sensors, right? Some examples would be cameras, just to see RGB the way we do. Other examples would be LiDAR scans and things like that, depth information through depth images. All of that information gives the robot a sense of what its surroundings look like. And then the artificial intelligence algorithms or policies or models broadly, they are able to use that sensor information to, first of all, get an understanding of the world and then figure out how to interact with the world or what type of motion is physically possible. So all of that comes within the AI part that goes in these physical AI systems. Now, the biggest challenge, or one of the biggest challenges right now to developing physical AI, is that it requires a lot of data, a lot of high quality data to train these models in the first place to do these tasks. So going back to a typical like machine learning or a conventional deep learning example, you need data to train that model to perform a specific detection task or a segmentation task. So in the same way, you need a lot of data captured on the particular robot type to be able to train that robot type to do other tasks. Now, the problem with this is that you can collect it in the real world using maybe teleoperation devices, like in the GIF on the left. You see a person manually showing the robot how to do a demonstration. All of that can be done, and it does create like very high quality data, except that it's very expensive to capture. So first of all, you need the physical robot. You need very often the motors can, if you use them constantly for like a very large amount of time for training, they do heat up, burn out. So there's like some physical constraints to it as well. And of course, just the fact that you have to replicate that robot in a bunch of different scenarios if you want to capture data for different tasks. So all of that takes a lot of time. It's also very expensive. And physically, for people to be able to like manually teleop and create that data needs like a huge team of people just collecting data. So that's one limitation. Now, the second limitation is that let's say you've even collected all of that data and you've trained a model to perform a specific task. Just being able to deploy that model on a physical robot to test is very dangerous and expensive again, because very likely the first iteration of your model is not going to perform as well as you expect it to, which leaves a lot of room for like robots falling, breaking stuff. And again, that becomes a very expensive problem. So this data scarcity problem and the fact that we are limited in collecting high quality data in the real world, that's one of the biggest challenges. Now, one solution that we've observed works very well to solve that challenge is using synthetic data. And synthetic data is data that has been collected from a simulation. So a digital version or a digital twin of the real world that looks very real. Like in this image here, this is actually a synthetic video of a factory. But that is the synthetic data that in fact can be used in place of or along with real data to train these robot models. So what you essentially have to do is use some sort of simulation platform, maybe like NVIDIA Isaac Sim, and build this scene within your simulation. The scene can very closely mimic your real world use case. So if you're building a robot that's going to work in a factory, your scene might look something like this, where you actually have boxes, pallets, and things that are in a warehouse. If your robot is going to work in, let's say, a household environment, then you would build a scene of like maybe a kitchen or wherever you expect the robot to work. So that digital twin you can create in simulation first. And then from simulation, you can collect data. That's called synthetic data. And then this synthetic data can be used in combination with real data you've collected to train and test robot models. Now, the value prop here is that synthetic data can be created way more faster and at scale compared to real data. Because in real data, when you're collecting it, like as a person, maybe you do one demonstration and that's counted as one data point, right, in your data set. Whereas with synthetic data, you can actually give maybe from one scene and different prompts, you can generate a whole bunch of data. And we'll see very soon how to do that. But this is the whole idea, that scaling up data generation Now, two things important in synthetic data are that it's photorealistic, which means it closely mimics real world lighting and textures, material, color, like every visual feature that you can imagine in the real world. It has to be mimicked very closely in simulation. That's one thing. The second thing is it has to be physically accurate. So of course, like you don't want boxes flying around because that's against gravity, or other physical properties like friction, maybe how objects interact due to friction, and maybe that's why a robot can grasp something. All of this needs to be imitated as well in simulation. Without these two things, photorealism and physics-based, you can't really have synthetic data that will be robust enough to train a model. So this is where we start talking about NVIDIA Cosmos. And Cosmos is this platform for world foundation model development. Let's see what that means. But the whole aim of Cosmos is to solve this problem where you have data in simulation and you want to build world models from it. How do you actually build world models that are photorealistic and physically accurate as well for advancing physical AI? So here on this slide, this is like the broad umbrella of Cosmos. On the left, you have your set of pre-trained models. So these are called the world foundation models. There's three broad types here. There's Cosmos Predict, Transfer, and Reason. And we'll talk one by one about each of them. But together, all of these models actually let you create world states, or they let you create videos of what your world will look like based on physics properties that it has learned already, and photorealistic features like lighting and realistic looking textures, things like that. So the first type of Cosmos model is Cosmos Predict. And as the name suggests, this kind of predicts future frames given some input frames. So input to Cosmos Predict can be an image or a video or even just text. And based on a text prompt that you give the model, like maybe generate the next few frames of this car driving on a road, it's able to predict or generate future frames of that video. So it can actually accurately pick up from where your input stops and generate the next few world states, how the world will look like. Now, this is useful because let's say you've been collecting data, right? And you want to kind of scale up that data collection process wherein you want to see what happens next, or you want to create that simulation of the world. That's where you would use Cosmos Predict. Then the next type of model is Cosmos Transfer. This one gives you more fine-grained control over the scene, because in Cosmos Transfer, what you do is you actually build a scene in some simulation platform like Isaac Sim. So you actually put the assets over there and you organize, you arrange how you want objects and people and other things in your scene to be placed in simulation. So you have the control of scene composition completely over here. And then just through textual prompts, so you can give different prompts, like this is a brightly lit factory, or the factory colors, boxes are like dark brown, something like that. So you give visual descriptions, and Cosmos Transfer takes your visual description as well as the scene that you built, and it generates a photorealistic looking scene from that. So in today's live stream, we are going to zoom in onto the transfer model specifically. Before doing that, let me talk about the third type of Cosmos model, which is Cosmos Reason. So this reasoning model, as the name suggests, it's for reasoning on general normal things that happen in the world based on physics. What I mean by that is that if you have, let's say, a driving scenario where you have a car approaching an intersection, and you want, let's say the car is autonomous and it needs to figure out its next move, like whether it has to stop or take a turn, that input of the video that it's seeing, so the image frames, and some textual prompt to the Cosmos Reason model, the prompt would look something like this. You are an autonomous car and you are approaching an intersection. Based on what you see in the image, what should you do? What should the next action be? That is something that Cosmos Reason can reason about and give an answer to in natural language. So it uses this long chain of thought processing to look at the input, look at the text prompt, and really, based on general knowledge, it can understand what's happening in the environment and what action it should take next. So this is useful for VLA, visual language action models, for autonomous vehicles, or even just embodied agents like robots as well, because it gives the robot some understanding about what's happening in the world and how it can take action. So broad, these are the types. Yeah.
I think that example that you just mentioned about, looking at a video in I'm guessing that comes from the Cosmos Reason paper that they published. And It was really interesting that they gave, with the video that they gave it in that paper, it was a trick question. There was no intersection there.
Yeah.
And the early models just hallucinated and just came up with a garbage answer, whereas Cosmos Reason was able to just say, there's no correct answer to that. You can't turn. It basically figured out and understood that it was a trick question. So
Yeah.
Anyway, I just thought it was so impressive. I mean, all of these models are so impressive, and they all do different things. But Cosmos Reason, they're all amazing. I love them. But,
Oh yeah, completely agree.
yeah.
Absolutely. And the best part is that all of these models are available on Hugging Face already. So for anyone who really wants to download them and try them out, you can do that. Like all you need to do is like sign the license and stuff on Hugging Face, and then you can just download and try them out. And then on GitHub, we have all the scripts for running inference, post-training on some of these models, different examples with specific use cases, like for robotics versus for autonomous vehicles. All of these things are on GitHub. And so, yeah, really encourage anyone who wants to give it a try to just go and download. And you can, of course, if you run into issues or like any enhancements, all of that can go up on the GitHub page. Cool. So yeah, other than these models, Cosmos platform also has some other things, like there is data curation. So based on like all the data that you want to train or pre-train these models on, of course, not all of that data will be high quality. So the curation pipeline helps you really kind of filter out and keep only the highest quality of data that'll help result in a better model. And then that curation pipeline can be used for non-Cosmos use cases as well. But here, that's what we've used to pre-train these models. And then there's post-training scripts on GitHub. So what that means is that if you already have the pre-trained Cosmos model, if it works for your use case just out of the box, that's great. But if you have a more specific use case wherein, let's say in your application, it's seeing a certain type of scenarios happen more often than others, then you could post-train these Cosmos pre-trained models on specific data for your use case. And then you would actually see an improvement in performance for that particular use case. So post-training is, of course, it takes more compute power, some more time, but it does result eventually in a model that's more optimized for a use case. So that's when you would do that. And then finally, there are some guardrail models. These are kind of built in by default with Cosmos models. And that's mainly for safe usage. So any input that's going into the model or output that has been generated from Cosmos, the guardrails just kick in and really check if that's safe to use, appropriate content. It also does some additional things like for privacy. I think it blurs out human faces. So these are just some of the ways that it guarantees safe usage. And overall, this is the Cosmos platform. Now we'll kind of be looking at a very zoomed in use case of Cosmos transfer.
And we saw some of that post-training in the Cosmos Dreams live stream recently, where they used Cosmos Predict to make videos of specific robots taking actions. And they had to post-train Cosmos Predict on the specific robot so that the videos it produced looked like that specific robot and obeyed the physics and kinematics of that robot. So anyway, I just thought for those who have been watching, they may remember that or may have seen that.
Oh, that's actually a great point, Eric. Yeah, I wanted to remind everyone, when did we have that Drive Dreams live stream? I think it was 2-3 weeks ago.
Yeah,
about.
If
and that was all about,
that
used a lot of Cosmos Predict.
Yeah.
And today we'll be talking a lot about Cosmos Transfer. So, yeah.
Absolutely, yeah. Because each of these models has so many applications, it's good to do like one live stream per model. It's impossible to do all of them in one. So
yeah, that's a really good point. Is we're not even, I mean, we're talking about these different models, but we're only talking about a single application of each model, really. And they have so many applications. Yeah, absolutely.
For sure. Yeah, exactly. Per robot, for example, based on a different humanoid, or if you're going to use like manipulator robot arms, for each robot type, also you would want to post-train these models so that you get best performance on that. So yeah, it has to be kind of case-by-case basis. But yeah, that's the whole point. I think that's what Cosmos, like the pre-trained models, that's the idea, that you post-train them for your application.
And for everyone watching either live or after the fact, we're dropping the links in the live chat as Asari and Eric are discussing them. I'll put a couple on the screen really quick. But for example, here's the Cosmos webpage. Then we have the GitHub link. We'll also add these to the description. So no worries if you don't catch it in the live. We'll put it down below.
Thank you. Yeah. So now let's talk about Cosmos Transfer. This particular model, it takes your input as a world state in the form of a multi-control input. So basically what that means is that, let's say you have your world generated in simulation or in the real world too, that's fine. But you can get different input types. So on the left, you see a segmentation image, you see an RGB image, a depth map. These kind of inputs can actually be passed to Cosmos Transfer. And as you can see in these inputs, there is not much other than the RGB one. There isn't a lot of visual features, right? There aren't like colors and textures, but that Cosmos transfer can add through a prompt alone. So in your prompt, for example, you would say something like, there are orange cones, there's a man wearing like that safety vest in a factory, maybe there's like some barricades marking off scary hazardous zones or something. All of these things you can give through prompt. And what the Cosmos transfer model does is it conditions the scene to look exactly like what you're giving it through the multi-control input, but then it kind of fills in the blanks and the textures and lighting based on your prompt. So you can kind of imagine in this way, if you gave like 10 different prompts with different colors, lighting conditions, whatever, you could generate 10 different output videos from essentially your one scene that you've created in simulation. So these are just some examples of inputs that Cosmos transfer can use. And it's honestly any combination of these. So if you have just one of these inputs, you could give that and Cosmos transfer can still work well. It could be any combination of these. And how you specify the weights is within the Cosmos transfer inference, you can actually give a weightage to each control input type. So let's say, let me give you an example of why you'd want to do that. Let's say in your scene, it's important to maintain the geometry of things. So like, what is the background, foreground, the shape of something? All of that information is easily captured in the depth image. So in this case, you might want to give the depth image a higher weightage than RGB, for example. Another control input type, which is not on this slide, but it kind of just looks like canny edges. So that's just edges of different things. That's good to use when you really want to change the colors and the textures completely. You would just give the highest weightage to the edges such that it maintains those edges in the output, but really fills in the blanks with anything else based on your prompt. So these are how you can, this is why I say that Cosmos transfer gives you more control, because you control the scene composition, you build everything in a simulation in something like Isaac Sim the way you want. And you provide the prompt, of course, and then you kind of just see transfer generating all of these outputs for you. So this is one.
These inputs, so with Cosmos Predict, the input is a single image. And with this, those are 3 videos. They're not images. They're like the full video of what you want to be kind of redone. Is that right?
Yes, that's right. Yeah. Predict can also use videos. So Predict can be like image or video.
Okay.
And then with transfer, it's like any combination of like whatever control input you have available. The video for that. And also in the real world, how this, like we're talking about simulation right now, but in the real world, sometimes robots in factories don't really have an RGB camera, but they might just have like a depth camera, or they might just have like a LiDAR. So based on what sensors you actually have on your physical embodiment, that's where this input type is coming from. Like your choice of input will then be based on what you have available, something like that.
So there are different, maybe we could call those sensor embodiments.
Mm-hmm.
And so depending on the sensor embodiment you want to get out of Cosmos transfer, you would give it different inputs.
Exactly.
That somewhat match or correlate with the output that you want.
Yep. Yeah.
Okay.
In the output, you kind of know what you want your scene or your factory or, your road, whatever scene it is, you know what it should look like.
Right.
Obviously, setting that up in the real world is impossible, whereas setting it up in simulation is very doable. That's the idea.
That's amazing.
It's pretty cool. Yeah.
And I just can't wait. And I know we have Ian and Aigul waiting, who have used this to actually improve robotics.
Yes. And that is very cool.
So I'm going to be quiet so we can get to them.
Yes. So these are just some examples of inputs that you can get from Isaac Sim. We saw some of these in the last slide, but RGB, depth, different types of segmentation. There's one more that you can canny edges, so just edges of things. Between these 2 segmentation types, you could use any. It's not really a big difference, but essentially in instance segmentation, each box or like each thing in the same class is still given its own label. In semantic segmentation, all things of that class are given the same label. So you can kind of see that in the colors, right? Like in semantic segmentation, all boxes are this green. In instance, each box has its own label. So that's the only difference. Again, in Cosmos transfer, if you want each box to be a different color, you would use instance segmentation versus semantic. So that's the whole idea here, that based on how you want your output to look like, you would decide the control inputs that go in. And just again, a high level of how this works is your real world data, which is maybe an actual factory that you want to model in simulation, that you convert into the USD format, which Isaac Sim uses, or Omniverse uses. You pass that into NVIDIA Omniverse, and then your scene kind of looks like this. So there's not much visual information in the first image, but there is just enough labels or segmentation masks to tell you like these are different parts of the robot or these are different parts of the background. Then all of these videos we call ground truth. So ground truth comes in through your simulation like Isaac Sim into Cosmos Transfer. You also pass a prompt. So your prompt can be as detailed or as less detailed as you want. But really you just have to specify like what background lighting you want. Is it bright? Is it dim? Maybe what is the color of the robot and the objects that it's interacting with. All of that information really you just give through language, through text, and Transfer can generate a very closely modeled output for you. And this is how you scale up as well. Basically, you maybe can automate the process of generating all of these prompts based on the same scene, and then you can very quickly get a lot of data. So because we're talking about control inputs, there are different inputs that you might want to use for autonomous vehicles. So like for AVs, sometimes what was like more important is maybe the lane markers and like traffic lights and posts and things like that. So typically all of that information used in driving scenarios, it's very well captured in HD maps. So that's the within the input type, the one that you see on the right, that's called an HD map. It just builds out these fine edges and 3D bounding boxes as well. So as you see cars moving ahead, taking turns, all of those 3D bounding boxes in time, that's the kind of information you would use as a control input for the AV use case specifically. And Cosmos Transfer can work with that. Within input on the left, you see a LiDAR scan. So a lot of AVs typically have onboard LiDARs, and they capture scans of all the obstacles and things around them. So these two input types can be passed to Cosmos Transfer, and from Transfer, you can generate the output based on different prompts. So again, you can say something like, this is a nighttime scene, so the lighting will be darker, or it's a scene driving through a mountain road, and then it'll actually generate mountains and stuff around. So it's honestly very cool how just given this kind of skeletal input in terms of the bounding boxes and scans, but you can give very rich prompts and get very different looking outputs. So that's the idea for AV. Now, one thing to note here is that Cosmos Transfer is not exclusively used with simulation. So I did say Isaac Sim a lot, and of course it's useful because in simulation you can build scenes very quickly. But let's say you already have a scene built in the real world, something like on the left image here. You already have a physical robot and some cubes, and it's doing like a cube stacking task on a table. Let's say you already have this in the real world, but you want to augment it and create a lot of data from it, but you don't necessarily want to like swap out the table or change the lighting or change maybe the type of arm that you're using. These things like changing in the real world, imagine how painful that would be to make all these changes. So instead, you would pass that input video captured in the real world to Cosmos Transfer, and you would pass a prompt, something like change the table to a metallic gray texture or change it to a darker wooden texture, things like that. Make the lighting more dim in the room. And through prompts alone, Cosmos Transfer will generate those very realistic looking videos that you're seeing on the right. So not only are they realistic, but they also follow the physics of the real world. Of course, you've captured this in the real world, so you know exactly that you want your scene to look like that. But Transfer will scale up that augmentation process. Now, why this is useful is that whenever you want to train a VLA, a visual language model, action model for a particular robot task, it needs to have data from different visual settings as well. So if you train it specifically on like the white wooden table that you see on the left, it may get confused how to generate actions on a darker wooden table. And that's the problem. Like you want to give it as many scenarios as possible in the training process, such that it's able to kind of adapt to a novel scenario. Like when it sees a different table, it still knows what action to do. So that's where all of this data is eventually going to be used. So with that, this was the Cosmos Transfer part, just some concepts about how to go from simulation to real, how to use it in the real to real context, and how it can augment data and create these huge data sets that you can use for training VLA models. Now, this is the very interesting use case of how we've used it internally to build and improve on some use cases. I will invite Jan and Igul to take it away.
Thank you. That was so great. Lots of great questions and comments coming in. We're going to answer the questions towards the latter part of the live stream, so keep them coming.
Awesome. Yeah, thank you so much, Asa, for sharing the Cosmos. And we will share how we are using the Cosmos to improve the mobility models. So I will give a brief overview around how we are using that. And also Aigu will dive deep into how great the results is after applying the Cosmos transfer to it. So for the mobility, we released multiple mobility-related workflows last year, including the end-to-end mobility foundation model training recipe and also the data set called X Mobility, which is a foundation model for the end-to-end cross-embodiment mobility. And so end-to-end in terms of image in and robot state and action out. And also the data we used for that is coming from the Mobility Gen with ISAC-SIM. We also released that. And currently Mobility Gen is also a part of the ISAC-SIM 5.0 as a part of that product as well. And for the data we use for this foundation model, we firstly generate that data from Mobility Gen and then use that generated videos as input for the transfer, including the segmentation and also the image. And then using that, we actually get model training and we can compare before and after the Cosmos transfer is applied. And also we test that pipeline in both the simulation and also with a real robot. And also recently we also got the campus released as well, which is on top of the imitation learning of the X Mobility is also adding the reinforced learning pipeline. And with that, all the positive impact from the Cosmos transfer still applies because the first stage of the imitation learning, then all the great impact from that will be applied to the second stage of RL fine-tuning as well, and then to the distillation stage at the campus. If we go to the next slide. Yeah, so essentially, Mobility Gen is a pipeline and toolset built on top of the ISAC-SIM to easily collect the data for the mobile robots. Could we click that video again? It seems like it's still loading. Yeah, with that, it's basically you can load your different robots, including, for example, the mobile robots, quadruped, the humanoid, and also your USD. And then you can collect your data autonomously or with teleoperation in that Mobility Gen pipeline. Again, it's already available in the ISAC-SIM 5.0 as a part of the product as well. If we go to the next slide.
So with the Mobility Gen, you can collect automated data. So would you just generate paths and then the robots follow the paths that you specify? Is that how that works?
Yeah, that's a great question. So actually, if we go to the next slide, we will show the difference.
I think we're going to switch presenters on the slide. So because that one was a little stuck. So we're going to show the slides in 1 second while we're waiting for that to come up.
Should we answer a few questions while we wait?
Yeah, I can answer that question actually before we get to that diagram. So basically, the Mobility Gen, we can generate data in multiple different ways. So the first way is that you can get that from the teleoperation as well. Yeah, so this is an example that you can get a different modality of the perception, and also you can get action data out of this pipeline. And also recently, we also added support for the robot format as well. And as you might see from Asa's presentation previously, Aural's modality can also be fit into the Cosmos transfer as an input. So you can get the more photorealistic and different texture of the environment after that as well. Yeah.
And that's the Cosmos, that realistic one. Is that a Cosmos transfer video that we're seeing?
So here in this videos, all that coming from the ISAC-SIM. Yeah.
So that's from ISAC-SIM.
From ISAC-SIM. ISAC-SIM already have really great rendering. Yeah.
Wow.
Cosmos transfer make it even better, even more realistic. Yeah.
And Matt B is asking about the views, you can probably do whatever sensors you want, I would
Yes,
guess.
exactly. You can add all those customized sensor as well. If we go to the next slide. Yeah, so basically, you can use your own USD things, and then you bring your different robot classes. We already have several built-in robot classes, including humanoid, mobile robots, and quadruped as well. And you do the mobility gen recording with any control method you like. Actually, we support the keyboard teleoperation. We also support the autonomous path planning based on the occupancy map. So you choose whichever way you like, and you can even bring in your own planning module to replace that class as well, so that you have different ways to autonomously collect that data.
So you could bring nav2 in for your planning.
Yes.
And then just run simulations and just collect data however you like.
Yes, exactly. And then you can also essentially changing the sensor configurations as like we just mentioned. And then after that,
so flexible.
Yes, it's very flexible.
Any robot whatever robotic embodiment you want, whatever sensor configuration you want, whatever planning, however you want to do the planning or teleop.
Yep.
That's great.
Bringing your robot USD and also your scenario USD. We also provide several examples, and also your controller to control that robots. In terms of, for example, humanoid, you do need a locomotion controller for your specific humanoid as well. Of course, we also provide
because you might even need like your own RL based locomotion model if you're using humanoid or quadruped.
Yes. For the Unitree H1, we already provided that to you. For the unique humanoid you are building in-house, then you can bring your own controller as well. Yeah.
Sure.
Yeah, and then after that, you get recorded data, right? Like that, and all those recorded data, you can feed that into the Cosmos transfer to get the photorealistic rendering. And also you get the additional action data from the mobility gen pipeline. Then you have all the data you need for the model training or algorithm testing. The model training can include, for example, perception related models or the end-to-end foundation models as well. And the algorithm testing, you can also use that for the different testing purpose. For example, QVSLAM can also be used to test that as well. Yeah. Okay, cool. Then we go to next slide. Yeah, so then what we are doing here is essentially using the Cosmos transfer to further boost the performance of the X mobility, which is an end-to-end foundation model that build on top of the word modeling. So we have two components in this architecture. The first part is word modeling. The second part is action policy. And with that, we achieve the zero-shot sim-to-real transfer and generalizable navigation in different environments. And with that, I will give to Aigu to further discuss how we are using the Cosmos transfer to improve the performance.
Hold on to your hats, everybody. Here we go.
So cool. Thank you, Yan, for this introduction. Yeah, now we're moving on to how we specifically applied Cosmos transfer to the X-mobility task. As Yan already mentioned, the original X-mobility dataset was generated in mobility gen warehouse environments. So using RGB and segmentation inputs from this dataset, we created multimodal inputs for Cosmos transfer. Cosmos then augmented this dataset by introducing lighting, visual appearances changes, and materials changes without changing the original geometry or motion. This approach helped to preserve the original ground truth data, such as roads and semantic segmentation, while producing more realistic and varied datasets for training. Then we combined the augmented data and the original data in equal proportions to create a hybrid dataset, which then was used to train a new model. Testing in Isaac Sim showed similar performance between the new model and the original one. But to truly evaluate sim-to-real improvement, real-world testing was required. So this brings us to the most interesting part of this evaluation, real-world testing on the robot using NVIDIA Carter with Isocross. The first scenario involved a single out-of-distribution obstacle, a transparent plastic box, and as you can see, the original model collided with it in all trials, while the new model avoided it every time. Such transparent objects are common in real-world warehouse environments, and this demonstrated that Cosmos Transfer can help handle such visually ambiguous obstacles.
I think it's so fascinating that you did not see improvements in simulation. And
Yeah.
probably in sim, X mobility could avoid those objects. Is that right?
Yes. No, we haven't tested out-of-distribution objects in Isaac Sim.
Oh, okay.
Yeah.
But you didn't really see improvement in Isaac Sim. But
Yeah.
then once you transferred to the real world, that's where you saw the improvement.
Yeah, that's right. Exactly.
It just takes me a minute to wrap my head around that, you know?
Mm-hmm.
Yeah. I love it.
Yeah, thank you. And next, we tested a thin gray ball that closely matched the floor color, making it difficult to detect. And you now will see that the original model collided with it consistently, while the new model avoided it in some runs. This indicates an improvement in handling such low contrast objects, although this test scenario remained challenging for both models. Another interesting observation emerged during cone navigation tests. X-mobility model trained with Cosmos data tended to navigate closer to obstacles, while the original model preferred wider paths. This trend repeated in the next scenario as well. It involved two consecutive goals behind the pallet and behind the cone. With the original model, once Carter moved to the wrong direction after reaching the first goal and became eventually stuck among the boxes.
Poor Carter. Stuck in the boxes.
And the new model, however, navigated correctly every time. But most notably, we measured the trip distance metric in this test case. And X-mobility model trained with Cosmos augmented data showed a shorter trip distance. These results suggest that Cosmos Transfer can help navigate narrow and visually challenging passages.
I feel like Carter 1 was in timeout.
Yeah, exactly. For these matters, to confirm this suggestion, we used recently released NVIDIA robotics real-to-sim asset, which is a great alternative to real-world testing because it allows us to evaluate this into real improvement much faster and easier without real robot using just Isaac Sim environment. And in this test case, Carter needed to turn around the shelf, and a gray wall and gray floor combination made this test case more challenging. And now you will see that the original model failed in 100% of cases by hitting the wall, while the new model navigated correctly every time. This fully confirmed that Cosmos Transfer improved the ability to handle narrow and visually challenging passages, as we said before. Finally, we collected key metrics for all these challenging scenarios, and it includes success rate. It's the percent of trials where robots reached the goal. Weighted trip time. It's a trip time divided by success rate. And finally, angular acceleration as an indicator of motion smoothness. These results are preliminary, but the improvements are clear. Training X-mobility policy with Cosmos Transfer augmented data improves its ability to handle transparent, low contrast, and poorly lit obstacles. Also, it tends to take shorter and more efficient paths. All these trends highlight Cosmos Transfer as a powerful tool for enhancing robustness and adaptability of robotics applications.
I think it's such a great example of using synthetic data to model those edge cases, because it's so hard if you're trying to capture data in the real world. It's so hard to capture those edge cases and those difficult scenarios. But here you can just choose to make synthetic data that models those edge cases. And with Cosmos Transfer, you've at least doubled, because you just did a 1-to-1 ratio between the Isaac Sim generated data and the Cosmos data. But you could, I would be really curious to see what if you did like a 1-to-10 ratio or 1-to-100, because each time you run Cosmos Transfer, it's going to give you more variety in that data. And yeah, anyway, there's such a bright, I mean, there's even Cosmos Predict along the same lines as Cosmos Dreams to like generate whole new scenarios. And there's just so much to this. I just
That's true.
Yeah.
Like there's a lot of scenarios you want to capture in your data set, but can't really generate in the real world. So one example is like while training AVs, somebody runs into the road or some animal runs into the middle of the road. You don't want to replicate that in the real world, but you do need that data for the car to know what to do. So yeah, all of that, like edge cases, risky things you can do in simulation in a very safe way.
Yes, especially child in the road scenario. No real data, please. Only synthetic. Yes, I love it.
Exactly. Well, thank you so much, Igul and Jan, for explaining how you're using Cosmos in your use cases. We do have around 10 minutes, and I'm seeing a lot of great questions in the chat.
Yeah.
So how about we start tackling them one by one? And maybe I can start with the first one. Feel free to jump in whenever you guys want. So Jan, Igul, Eric, whenever you guys want to add to something, just feel free to jump in. So the first question I see, it says, should metadata like segmentation, depth, etc., be generated in Isaac Lab for Groot Mimic? Is it viable via the replicator API in Isaac Lab? Great question, because yes, we do have a tutorial that in fact generates those ground truth metadata in Isaac Sim. It uses the replicator API, and we'll share a link to that example in the chat. Yeah, basically it lets you build your scene in Isaac Sim or in Isaac Lab, and then you call that replicator extension, and it already has all that ground truth data. So you then create different videos for what you want. It creates, I think, 4 types for you today. So it does segmentation, depth, edges, and one more, I think RGB, low resolution RGB or something like that.
Well, you have different types of segmentation. Aren't there 2 different types of segmentation too?
Yes, there are, correct. And you use whichever one. But yeah, broadly, once you get that, you can just pass those as input videos to Cosmos Transfer. So we have an example doing that already. Next question says, can you also automate realistic world generation? Answer is yes, you can. How you would do that is basically how you would scale it up. You have maybe 1 or 2 or whatever, 10 videos you've captured in the real world. You would just pass all of them through transfer with maybe a different prompt or multiple different prompts per input video. And that's about it. From that, you get very realistic, visually diverse videos from essentially just 1 or 2.
I have seen a few questions that I think are kind of referring to Google DeepMind's new Genie 3 model. Mm-hmm. And I think that model is a little different than what we've got, and just in that it's more about world generation, where the inputs to the AI are actually teleop keyboard commands, and then it will generate follow-on images based on kind of navigational commands. Whereas the Cosmos models that we explained today, we have the 3 models we talked about, but Cosmos Predict will generate just a video from an initial video and a text prompt rather than keyboard commands. Cosmos Transfer will basically take a video of a scene and then just change out the way it looks, essentially. And Cosmos Reason can just think about a video it's seen and tell you if it makes sense or what should happen next and that sort of thing.
Mm-hmm. True, yeah. With the Cosmos models, the idea is more to give like an end-to-end solution. So for example, all the data you've generated from, let's say, Cosmos Predict or Transfer, you could use Cosmos Reason to annotate them or reason about if some of these videos are bad or like don't follow physics correctly, filter those out. So the idea is kind of use any of them or all of them together, and it lets you create a very solid, robust data set.
Yeah, and I would say that the Cosmos models we're talking about here are really geared towards robotics, and the Genie 3 model is really, they seem to be gearing it, just from what I've read, towards gaming and kind of gaming development.
For sure, yeah. I see another interesting question. Can you share some insights on how Cosmos Predict could boost robotics manipulation for existing Isaac Mimic workflows? Yes, great question. So Cosmos Predict is the first type of, like, of the three we talked about. Cosmos Predict was one of them. And how you would do that is that if you have, let's say, a scene that you've generated, either in the real world or in sim, from that, Cosmos Predict can generate the next few frames of what could potentially happen in the future. These are usually like coherent and consistent with, again, the laws of physics. From these videos, you can do, like, you can run an IDM, which is an inverse dynamics model. And that actually, from pixels or from video information, it lets you generate the joint positions and like what actions are required for the robot arm, the manipulator, to reach that final action position. So based on video, it can give you the action sequences or trajectories. We can call them trajectories in this case. And then these trajectories are actually used for test, like training a model for manipulation tasks. So it's a complex workflow, but it does have a name. You can check it out. It's called Isaac Groot Dreams.
Yeah.
And Groot Dreams kind of does exactly this. Like, it uses Predict, it runs IDM on it, and it's able to generate actions from video. Same with Cosmos Drive Dreams. That's another use case for the AV domain. But yeah, that's how you're using Cosmos Predict to boost manipulation workflows or pipelines.
Well, and one thing I think is really interesting about that workflow is that you start off with the Cosmos Predict model and some IDM foundation model, and you would do maybe a few 10 or 20 demonstrations or yourself with the robot that you want to post train, and then you'd use those 10 or 20 videos that you've ground truth videos, and use those to post train both the Cosmos Predict model and to post train the IDM model, so that it can so that you can kind of do that whole process. It's just nice because you use just like a few demonstrations really to post train both of those models, and then you can use those two models together to generate entire demonstrations with trajectories you can use, and then post train Groot with those. If that makes sense. I hope that made sense. I think it's cool.
Yeah, exactly. That's another use case of like Cosmos within the Groot project, like how we're using it for training. Yeah, so as you guys can see, there's a whole range of, I guess, different domains as well as workflows where we're already using this. Okay, so let's move on to some of the other questions. Which types of errors does the model struggle with more when using LiDAR and HD map inputs, like occlusion and label noise? That's a good question. I don't actually know, like, between these two, which type of errors it struggles with more. My guess is that the paper will have a lot of information about this and like how choices are made based on how error accumulates. So I don't have the answer right now, but I would point you to the paper to find out about that.
Do we have a link to the paper in the chat?
Yeah,
I did. I posted earlier, but I can repost it. We also had a question a little earlier about the hardware requirements for Cosmos Transfer. And because each Cosmos model has its own compute requirements, and it depends whether you're just running inference or doing post-training, you should check for the exact specs for each model on the GitHub or Hugging Face pages. And we post those links also in the chat.
I would jump in and say that someone else asked if you could deploy these to like a Jetson. And typically Cosmos is run on the cloud with fairly high-powered GPUs. But then the X Mobility Foundation Foundation model, once you've post-trained it, that you would deploy onto a Jetson. Is that right, Yan?
Yes, exactly. We deploy that directly to Jensen.
Yeah.
Yeah, so typically, as of now, at least, we don't really have to run Cosmos on the edge, like on a Jetson device. But in fact, you would use it for the data generation process and the data augmentation process. Yep.
Yeah.
And then you would also you do generate this big data set, right? Using cloud services and high powered GPUs, and then you'll train and do your post training and train your model also with the cloud. But then once you have a model that's trained, then you deploy that to the edge. Is that good? Yeah.
Yes. Yep.
Yeah.
That makes sense. Yeah. Okay, I think we can do a couple of more questions. Question, is the SO-ARM Cosmos example public? So I like this question because the SO 100 or 101 ARMs, these are relatively low cost. So it's easier for enthusiasts and developers to really get started on this. We do have some experiments where we've done, like very recently, we've actually done Cosmos augmentation and then trained the GR00T model for the SO-ARM. If it's not public yet, I imagine it might be at some point, because this is an ARM that obviously I think more people have access to. So we do want to show how the whole workflow works on that. So Cosmos plus GR00T on SO11, I think we're working on that. Just I'm not sure if it's public yet, but we will be having some tutorials out there on this, how to do this. We do have a blog already, actually. I think it's on Hugging Face, but the blog walks you through using the SO ARM and then fine-tuning GR00T on it. So we have a little bit information already public out there.
And that question comes from Lychee AI, aka Murmur Bay, Omniverse ambassador. So thanks for tuning in, and what a great question.
I like that his actual name is your AKA.
Just in case. Actually, he's just wrapping up an Isaac Sim Isaac Lab tournament, so we'll talk about that on a future live stream we're planning right now.
Yeah.
Do we have time for a couple more questions?
Someone asked about.
I see a mobility gen related one. Maybe Jan can take that.
Sure.
But the question basically says, does mobility gen take into account pose for achieving a certain movement? For instance, can we use it to generate a quadruped spider walking using the video diffusion results?
Yes. So it's essentially you can add additional action to it. And for quadruped, we also have an example of the Boston Dynamics quadruped. You can maybe modify it to fit your use case as well.
And it sounds like from our discussion that mobility gen does not generate the locomotion typically. Mobility gen, you would typically have your locomotion policy and you'd put that, kind of connect that with your robot in Isaac Sim, and then you would simulate the robot with that existing locomotion policy moving around the environment and then capture that data.
Exactly.
Then you use that captured data set to train more like a navigation model, like a local or even more of a local. So with navigation, you typically have like the global navigation, which is if you've got to go from one end of a warehouse to the other, that's your global navigation. And that has a really slow, like your occupancy map in your settings for that really change slowly, like, or updated infrequently. And then you typically have your local navigation, which is more like if it's following its prescribed path and then there's a box in the way, then it can leave its global navigation directions and walk around the obstacle. And it sounds like, it seems, and I could be wrong, I mean, I'm curious, but it seems like X Mobility is more of a local navigation policy or no local navigation solution. Is that right?
Yes. So we can use two modes to deploy it. One mode is mapless, where you can use a visual odometry to reach the target, or use a map and then you use like the generated waypoints, which can coming from Swagger. We recently also used to generate those high-level waypoints as a global planning and feed that into the X Mobility as input as well. So either way, we are supported. We support that, depends on the use case. For example, for the small kind of like space, then mapless mode also works. For the large space, let's say a big warehouse with a lot of aisles, then we would recommend to connect that with a waypoint generator, generate those high-level waypoints, for example, in the next next intersection, turn left or turn right in the warehouse. Yeah.
Right. Because I suppose if you have a small environment, then it can just kind of do the global and local navigation. If there's a low chance of it getting stuck at some dead end of a maze, right?
Yep.
But if with a large warehouse where it's maybe more maze-like, then you need to give it a little more help.
Yeah, exactly. Yeah.
Okay.
Yeah,
that makes sense.
Awesome. There's one question about model sensors. How do you model sensors? Not all cameras are the same. Not all images are crisp. That's true. But Isaac Sim already has a bunch of inbuilt sensors. So cameras is one of them, LiDAR as well. And it doesn't, for Cosmos Transfer at least, the images don't really need to be crisp at all. There's not that requirement. Just because as long as the image has general, edges and can you see the objects in it, as long as that's seen in the video, Cosmos Transfer will still be able to augment and add visual features to it. So it's not a requirement for like images to be HD or anything like that.
I also want to point out that these neural networks interpolate. And so a lot of people, when they're working with their physics modeling and their sensor data, they're trying to match the real world. And that's not actually necessary. As long as whatever data you have bounds the real world, then the AIs can typically interpolate and perform well.
Yeah, for sure. Then there's a question about, can you simulate people for multiple robots acting as agents? So yes, I assume this is in the context of like the simulation side. Let's say in Isaac Sim, you can accurately simulate people and their motions and actions. And then once those are simulated in your input video to transfer, the output from transfer can give you a realistic image of how the robot would interact with people. So like once you enable physics in Isaac Sim for people, that's fairly accurately modeled as well. How would people walk or like interact with a robot or other moving obstacles? All of that you can simulate that. Another question I see is, could you give me a scenario where instance would outperform semantic segmentation? So this is probably like in the context of what do you actually generate from Isaac Sim? Would it be instance segmentation or semantic segmentation? And how would you decide what to use that? So an example would be, let's say you don't really care how all the boxes are rendered out of Cosmos Transfer. Let's say you don't mind if they all look the same. Then you would use semantic segmentation because you really just care about boxes as a class there, but not each individual instance of a box. So you'd use semantic segmentation there. Instance segmentation, you're right, it may take a little more compute to generate, but in that case, you will get very different textures and materials and colors per box because you've kind of through segmentation, you've shown that each box is a different instance. So it will treat each box differently instead of like one class. So that's just one example. Then I see a question about, is this an alternative to RViz 2? So by this, I assume you mean, is Cosmos Transfer or is the workflow?
Actually, it was that was when she brought up there's like a testing suite with the occupancy maps. It looks kind of like RViz. Yeah. I was just gonna say I don't think it's an alternate. It's not. It's actually more of a testing suite, and whereas RViz is purely for visualization. So no, I don't think they're alternatives. I think they serve different purposes.
Yeah, in that last slide that you showed, Igul, was it, what tool were you using?
Yeah, maybe she was even using RViz there.
In the very last one.
If you're talking about, sorry,
Yeah.
this, right? Yeah, it's RViz and Isaac Ross with Isaac Sim.
Yeah, so this is actually, they're using RViz to display this stuff.
Yeah.
But what they're displaying is this NUREC kind of robotics synthetic testing tool so that you can test your robot's mobility policy without deploying to real world.
Yeah, exactly. And occupancy map from this real to sim asset. Yeah.
Save some money.
Okay, a couple of more questions. Where can I find the mentioned Lerobot dataset format support? Is there a public repo for it? Yes, so there in our Isaac Groot repo, on GitHub, there is a conversion step where we show how to convert to the Layrobot format. I think there might be, I'm not sure if we just have a data set like that, but I know that you can convert any of your captured data into the Layrobot format using the GitHub for SIGGRAPH. So I would point you to that.
Yeah, and in the mobility gen repo, we also have that Layrobot format support as well. Yeah, and also the data loader for using the Layrobot format is also in the X Mobility GitHub as well.
Awesome. Okay. Hey, this another question. This might not be related, but could you simulate an input camera being dirty or partially broken? This is a great question because you don't have to actually simulate it on the simulation platform itself of an input camera being dirty. But in fact, you could do that through the prompt that you give to Cosmos Transfer. So for example, you can give whatever video you already have to Cosmos Transfer. In the prompt, you can specify that add random lighting, like flashing lights, or add like a patch or something on the camera to simulate it being dirty or broken. And Cosmos Transfer, like from the output, you'll be able to generate that kind of video as if the camera is dirty or broken. So that's the beauty of it, that you don't actually have to simulate a broken camera. You can simulate an okay camera, but through text prompt alone, you can get that broken effect in the output, if that makes sense. Okay, I see another question. If our project is having a data set, is it possible to integrate along with synthetic data? Yes, absolutely. If you already have a data set in your project, and even if it's synthetic data or if it's real data, either way, it's fine. You can augment it with the synthetic data that you would generate from Cosmos Transfer. And in fact, in our observations, we have actually seen that some combination of real and synthetic data works best for a lot of projects. So what ratio that is depends on, it's kind of heuristics. You have to do a bit of trial and error and see how much real and how much synthetic works the best for your use case. But usually, it's never the case that either one of them alone performs best. Most likely, you will be using some combination of synthetic data.
And I'll say I've been surprised at how little real data I need and how much synthetic data I can use.
Yeah, exactly. It doesn't have to be much real data at all.
No, not really.
Yeah. Okay. Does the model output resolution change? Does the model's resolution change the success rate much? Okay. For instance, if we output 320 by 320, is it just as successful as 1024? Have you, I guess this might be a question for Jan and for Aigul. Did you guys observe how output resolution changes performance?
We didn't specifically experiment on that.
Do you know what is your output resolution? Just curious. Is that really, I'm trying to think if that makes, because there's the.
My guess is that it shouldn't change success rate, but I really haven't tried. I don't know.
I will say that 1024 by 1024 seems like pretty high resolution for, I don't have a great intuition for this. What kind of camera resolution do we have on, like, that Carter has like a Intel, what kind of camera resolution does it have? It has depth cameras, right?
So it uses the Intel RealSense, if I'm correct. But I know that the resolution is something you can like change.
Yeah.
But this is a good, like, I think it's a good trial. It's something worth experimenting with.
I'm actually curious, in these samples with the Carter, what camera, what sensors were you using? I'm guessing you were not using the LiDAR, even though there's a LiDAR on it. Were you just using camera? And how many cameras?
Yes, so for the X Mobility single camera as input, and also we just use that camera that currently have in the USD from the Cutter robot, and that's also like the Cutter robot USD is also available publicly, and also the resolution we use there is 320 by 512 in terms of the shape.
Okay.
Yeah.
That's kind of what I mean, 1024 by 1024 seems like pretty high resolution.
Yes. Yep.
And it would be particularly hard to work with because it's would take a lot of compute to generate Cosmos transfer images in that high of resolution, I would guess. Is that, yeah, anyway.
Yeah,
I think this is another surprising, the thing that's been very surprising for me in my robotics journey is how low of resolution cameras you really need for the robots to use.
Yeah. And there's another thing that there is a way to like upscale the within the Cosmos platform. There's another model that can do upscaling. So I guess it fills in, like even if you give a lower resolution input, it can do its own task of like upscaling it and then running inference on it. So there are ways to, I guess, get your input up to whatever is required by transfer.
Right.
And transfer takes care of it, yeah, by itself.
Yeah, makes sense.
Cool. I think we can do maybe one more question or two more. There is a question about the timeline for release of the Cosmos Reason 1 model. I don't really have information right now about like the timeline for releases, but I will say that whenever, like, good places to check is Hugging Face. So within Hugging Face, we have different collections for each of the Cosmos type of model. So for Cosmos Predict, you'll have a collection, Cosmos Transfer, and then Reason. Each will have their own. So Hugging Face is the right place to basically keep checking. Also on the GitHub, on each GitHub for each model type, we have like an announcements tab or just a section where you can see what's being released as it's being released. So yeah, just keep checking there for like newer releases as they come.
I'd also say like the coolest stuff gets announced at the GTC conferences and at SIGGRAPH. And so stay in tune with those keynotes. And I think you'll hear about all the coolest stuff as it comes out, you know?
Yeah, that's true. Okay, we have one more question saying, can I generate labeled training data through Isaac Sim or via Omniverse? Yes, you can. So Isaac Sim has ground truth labels for a lot of different types. So you can have bounding boxes as labels or segmentation masks or depth pixels. Yes, all of that can be generated through Isaac Sim, built on top of Omniverse. And then final question, somebody saying they had to join a little late, but they have so many questions. Would love to follow up without repeating anything. Is there someone from NVIDIA you could reach out to? Yes, so we do have the Discord channel, which I think the conversation basically continues there. And then if you have more like technical questions, if you've actually started using the repo and the models and you're running into blocks or something with that, then the GitHub issues, of course, like that's where you can go and post those issues and maybe find solutions based on what other people have tried. And then for the Isaac Sim part of it that we talked about, like generating the scene before before Cosmos Transfer, for that we have the Isaac Sim forum. So then the forum is where, again, it's like a community chat, but people from NVIDIA will actually answer your questions on that forum. Yep, and there we go, the link for Discord.
And we even have an Isaac Lab study group that starts in 15 minutes.
My gosh,
on Discord.
What perfect timing. Yeah, 12 minutes right after this would be fantastic. If anyone wants to join up, I highly encourage you. And for people who are not regular viewers, all these live streams are available on the Omniverse YouTube channel. If you go to the live section, so you could look at this live stream right away from the beginning, watch in any speed you like, and then you could go to any of the other previous live streams. They're all saved there. Second thing regarding the Discord, we usually have a dedicated thread, as we do today, for this live stream specifically. So if you want to follow up with the speakers or any other viewers of this live stream or have any questions specific to this topic, just use the thread that's in the live stream channel on our Discord server for this stream. I posted a link in the chat. But if you go to the Discord server without the link, just go to the Discord server Omniverse. It's on the invite's on the screen right now. And then just go to live streams under developer resources and you'll see all of our previous live stream threads. Great resource there. Fantastic questions and presentations all around. Very impressive. This is probably the least I had to speak on any live stream, which is amazing. So I can get to watch and learn from all of you. A really fantastic, deep dive, and also covering the basics, people who are just diving in for the first time. I think you covered all the bases today. Really, really compelling presentations all around. I think it's going to be a fantastic resource for everybody. I'm so grateful, not only for our presenters and Eric for his amazing questions and intuition on knowing exactly what to ask and when, also to the amazing viewers out there who just had some great questions and comments throughout this live stream. We tried to answer as many as we can, but like I said, jump on that Discord, and we've had the GitHub links we've been sharing. We'll update the links to the description afterwards. Really, really fantastic hour. I also want to highlight really quick, if I can, we've got a couple of I want to just mention that we've got a couple of really interesting posts that were shared this week on our LinkedIn. Actually, well, this is from Omniverse Ambassador Michael Wagner from Epolog and SyncTwin. I like to highlight a couple of really cool things that people might have missed in the community. This is a perfect one, actually, because this is about leveraging GPUs in the cloud. If you don't have access to local hardware, he gives an example, step-by-step guide on how to leverage AWS and to run your first USD Composer Kit app. No local installation, no GPU setup headaches. It's very easy. The article actually goes step-by-step that he links to in that post. I'll put the link in the chat in a second. But he walks everybody through how to do it. Really cool. And then also for people who really want to leverage GPU in the cloud, NVIDIA Brev is a great resource. We're going to do a future live stream dedicated to Brev, but we'll also post this in the chat. There's a really quick start guide. If you do a search for NVIDIA Brev, BREV, you'll come across it. We'll also put a link in the chat. Another great way to leverage GPUs in the cloud.
Isn't Lychee giving away some Brev credits?
He actually is, yes. So that part of that tournament for Isaac Sim and Isaac Lab, I think the first, second, and third prizes add up to a total combined of $850 Brev credits that was donated by NVIDIA to help support the tournament winners. So really excited. Like I said earlier, we're going to try to do a live stream on the tournament, including the winners, to show off their projects, which just look fantastic. The team internally has been looking at these and just blown away by the work being generated by the community. Really hats off to everybody for leveraging all the tech the best ways. And then finally, I wanted to share just another developer that's been posting a lot of cool stuff lately, Marina Nastri, who is a developer from Brazil. She's been posting some really, really cool, insightful posts as she does her journey with Isaac Sim. This one focused on sensor integration. So highly recommend you follow these developers, but absolutely take advantage of all the resources, including each other out there. Lots of great people, and that's another great reason to come to the Discord server. So highly recommend that people leverage that to their best. Thank you again, everybody. I know I talked a lot and said a lot. Anyone want to add any final words, final closing comments? We'll start with Eric. Eric, your takeaway? My
takeaway is I'm so impressed with the NVIDIAns I get to meet with on this channel. Asawari has so much breadth and depth to her robotics knowledge. Aigul and Yan, I just love this project you've showed. And it's so practical. It's foundation model based. And so they're all going to be able to use it. Yeah, it makes me happy.
I second that. I come to work every day and just blown away by the talent here. Asari, do you want to leave with any closing comments? What you want people to just take away?
Yes. First of all, thank you all so much for joining. And I hope you were able to learn a little something today. And I hope it inspires you to actually go and try Cosmos. It's, they're all open models. Please give that a shot. And just thank you, Eric, Edmar, Aigul, Yan, everyone. It's so great joining these live streams. I have a lot of fun always, and I learned something. Had a great time. Yeah.
Thank you so much. And Yan, would you like to share any closing thoughts?
Yeah, really enjoyed this discussion, and thanks all for all the discussions, and thank you everyone joining us remotely as well. And it's always so much fun to discuss together and try out what we just shared.
Yeah.
And we all believe there is a potential great use cases for all those technologies.
I totally agree. And Aigul, you've stayed up the latest. You're way past your bedtime now, so you get the last words in.
Yeah. Thank you everyone for joining and all these great questions. It was so much fun, and I'm also so impressed by Asa and Jan's background. It was very fun. Thank you.
Well, that's perfectly said. Once again, thank you everybody for joining us. We'll see you very soon. Check out our Ed event calendar for upcoming live streams and events. Like Eric just mentioned, the Isaac Sim Isaac Lab Study Group, which takes place every Wednesday. If you're watching this live, it's happening in just a few minutes on our Discord server. Head over to the community room. You'll see a bunch of people collecting there now. Eric's going to head over there in a few minutes.
6 minutes.
6 minutes. You got 6. You heard
just enough time to go walk upstairs and walk back and move my legs a little.
Have a drink of water.
That's right.
And then for those attending SIGGRAPH, it's going to be a great time. Definitely feel free to reach out. I hope to meet you all that are coming. And if you're not attending SIGGRAPH, don't worry. We'll try to keep you updated on the SIGGRAPH channel on the Discord server, as well as some of those sessions will be broadcast live, I suppose, special sessions with NVIDIA speakers. And the other sessions, I think someone asked earlier, they'll be available a couple weeks afterwards through NVIDIA On Demand. So don't worry if you can't make it, but hope you get to come. All right. Thanks, everybody. It's been a great hour. Until next time. Thank you.
Thank
Thank
you.
you all. Bye-bye.